Hey everyone, thanks for joining in today. I'm Cody, I'm a technical account manager here at Synology, and I'm going to be your guide for this webinar and many more to come. This month we have some really exciting new features to show you guys and some great new hardware as well. So what we're going to be diving into is our first ever IP SAN, the UC3200 or Unified Controller 3200. It is an active iSCSI target and going to really help out those individuals that want to use Synology in an always up business critical enterprise environment. Another thing we're going to be touching base on is the new deployment of Active Backup for Business version 2.1. It has our long-awaited Hyper-V integration, and along with it, you're going to be seeing a lot of new functionality as well on the side that will be useful to you guys as IT admins working in very diverse environments. So let's just get into it right now. We have a few things on the agenda today. As mentioned, we're going to be touching on the hardware of the Unified Controller, what the anatomy of each controller looks like, and we will also be touching on the software, the UI, how that looks whenever we do failover and all that good stuff, and just show you guys truly that this is a non-interruptive iSCSI device. We're also going to touch base on a couple different solutions, mainly on the solutions surrounding, VM storage and that IP failover and all that good stuff. So on first to the hardware, what's great about the UC3200 is its modular dual active architecture, and it is the first Synology device in our product line to have this kind of setup and to have this kind of internal architecture. As mentioned, this is a dual controller device, so everything is completely identical. And so we're going to be also going over some specifications and performance along with the general active architecture that you're going to see in the device itself. So the UC3200, this is an actual render of the back of the device that you're going to see a little bit later in our hardware showcase. As you can see, it's a 2U unit, and like a lot of our other 2U units, you're actually able to expand it out to 36 bays. On the front of this device, it actually has 12 bays that can be used for SAS hard drives or SAS SSDs as well. Something that's really interesting with this device, and it's the first time we've actually kind of approached this subject with Synology, is the support for self-encrypting drives on this device. So it's understood that this is more of an enterprise device, and so you're going to want that extra layer of security on the drives themselves. So this is fully modular and it's hot swappable. The lever that you see right up here, these little levers right here, after you unscrew this thumb screw, you're actually going to be able to pull out on that lever, and it disengages the controller. What's great about that is you can do that while everything's on, even while data transfers are happening, all of that. So you can disengage that device, perform a RAM upgrade or something similar, and drop the device back in. And likewise, if you needed to RMA one of these portions, you could do so as well. We want to mention that this is iSCSI only, and we did this to kind of streamline the use of this device and make sure it's really locked in, it's totally ready for prime time and all that. So next we're going to actually jump into some of the numbers associated with this device. This device boasts 400K and 140K random read and write IOPS at 4K. What's great about this is if you take a look at some of our other flash station models, especially some of the ones that are being released in the future, we have kind of a tiered setup with those where we have kind of a little bit of power, medium power, and max power on our most powerful units. This actually sits pretty comparably to kind of like the mid-tier flash station area. It's boasting very impressive IOPS for, even though it's just an iSCSI target and is not actually a full-featured Synology NAS as some of our other devices are. Each of one of these controllers has, once more, fully identical architecture on the inside. So as you can see, we have actually a single Xeon D1521 on each controller. Likewise, each controller can have 64 gigabytes of DDR4 ECC memory, so a total of 128 gigabytes in the entire system. For network, it's really great because we have two 10G RJ45 ports and also two 2 PCIe NIC slots as well so that's one each of those for each controller. Those PCIe NIC slots will allow you to actually increase the amount of 10G connections you have on the device, or even go for a different interface if you so need. So let's take a look at this picture of a controller kind of pulled out, disengaged, and the top cover on the right there is pulled off. So the first thing I wanted to touch base on is the SATA DOM chip. It's actually going to be in the bottom right corner of the device. This is where the pre-installed Unified Controller OS will be. It's actually extremely similar to DSM. You don't need to learn a new operating system to operate the Unified Controller. It's going to be very straightforward for those who have already utilized a Synology NAS device in the past. So we did this for a couple of reasons. It helps in failover, but it also isolates system and data performance. So the OS isn't having to perform operations while the drives are on the same device. So normally the OS would be sitting on the hard drives, and those operating system operations would be performed at the same time those data operations are. So by isolating these, you actually get a better OS performance overall, and also you get better data performance as well. One of the coolest features of this device is the non-transparent bridge. It is how we actually do this failover internal to the unit instead of having an external heartbeat connection. The non-transparent bridge can offer us 32 gigabits per second bidirectionally, so it's really going to help with that failover time. We're shooting for a sub 30-second failover time in this device. It's an internal connection, and it's actually done over PCI bus, and that's part of why it has such good performance and the ability to fail over so quickly. Along with all this active-active architecture is the promise of service continuity. Your iSCSI service will always be up, so there's no downtime during failover or whenever you're upgrading or whenever you're doing a hardware swap even. Another great feature of this is the memory data protection. This mechanism is what allows you to fail over and all that kind of stuff and still retain that data integrity during failover. So it protects that cached data so that during failover that isn't purged or lost or anything like that. So let's go ahead and take a look at the demo here of the hardware and just kind of take a look at what it looks like disengaging the unit, what the lights do, and kind of the interface in general in the real world. As we fade in here, you can see that we have that same picture of that controller. On the top there, we have the PCIe daughter card that allows you to add a NIC, and it will lay horizontally in the back of the unit. Right below that is the 4 RAM slots that you can add a total of 64 gigs of RAM to. On the left here, that little black box with the air fins, that is where your CPU is. And at the very bottom on the right is the SATA DOM, which is where your OS is housed on each controller. As we transition here into another shot, you can see that we're zooming in on the UC under normal operation. As you can see, both these status lights are green and blinking in unison. And likewise, the SATA DOM light is good to go as well. So this is how it would look under completely normal operation if everything was good to go in a dual active setup. Transitioning once more, we're going to show you what it looks like whenever you disengage the unit fully and what happens to the controller that stays. As we pull out this device, you can see that there is no issue with the remaining SATA DOM chip, and the status light is still blinking as it did before. Ripping out this controller while it's on does not cause a hiccup in the system. Now, when we re-engage the device here, you're going to see that the SATA DOM immediately comes on and the link light is started. It's going through its boot procedure and making sure the controller is doing okay, and then it will start failing back all of those services that were previously on the device, iSCSI, its IP, the whole 9 yards in this situation. Once it's all good to go, you will see both green lights kind of back to normal, but here we're actually going to pull the same controller back out again and show you what it looks like on the front of the unit whenever you have one controller either malfunctioning or completely out of the unit itself. So here in a moment, you can see that we're pulling the controller out, and we're going to go ahead and transition to the front side of the unit. As you can see, it's a 12-bay 2 unit, similar to most of our other devices, and your indication is going to be an alarm as well as that orange blinking HA light on the left there. That'll be your visual cue that something is up with the unit. Lastly, on the back side, you can see we have controller B pulled out of the device, and you're going to see that we have the remaining controller have strong power and good status as well. We're going to be reinserting this device from the back end. As we slide it in, you're going to feel a nice kind of tactile feel as you feel the entire lever kind of re-engage. But make sure you push that last little silver tab and set the thumb screw once you do re-engage the controller, just for that added security. As you can see, the power light is blinking, it's booting up. Whenever you see both those top two lights as green, the controller is functioning well, and the status is green as well. So that means that you're pretty much back up and running. Likewise, on the front end, you would see that there was a, the HA light would be back to normal. It'd be just a solid light at that point. So there you have it. That's the hardware side of things, the front, the back, what it looks like whenever you're pulling out the unit in different shots. As you can see, there's really nice kind of tactile feel whenever you actually push in the controller. You can see the lever kind of like lock back into place most of the way, and just a simple thumb screw set, and then you're good to go. None of that failover has to occur through calibration or manual intervention. The only manual intervention is actually removing and reinstalling the controller. Everything else is monitored and triggered within the OS of the Unified Controller. So we're going to go ahead and reach into software now as well. So the UC is not a fully featured NAS as some of our other devices are as well. Synology is well known for being the largest NAS manufacturer in the world. But the UC is the first IP SAN that we have created. And so for that reason, we've actually kind of stripped down what applications run in it. You're going to notice that High Availability Manager is still there to manage the relationship of the two controllers, and will automatically open whenever you reach into the UI of the Unified Controller. iSCSI Manager is going to be where you can set up iSCSI LUNs and apply them to specified controllers and all that good stuff. Snapshot is one of those packages we thought was imperative to have on the UC because it is something that Synology is honestly renowned for. You're going to be able to snapshot from the UC itself to another Synology NAS or to other UCs as well. So you can have a distributed amount of those in various data centers and have snapshots still available to fail over LUNs and do anything else that you may need. So HA Manager is what is going to be managing the relationship between the two controllers. It's going to help manage the system update side of things and automatically switch over between controllers when the upgrade is happening. So if controller A was upgrading, it would have switched over all the services and IPs to controller B. Now, if controller B was upgrading, it would actually switch back over to controller A, and then pull all those IPs, let that finish doing its upgrade, and then once both controllers are finished, it'll redistribute the load as it previously was configured. HA Manager is what will kind of manage the SSD cache management. As we said, there was a kind of a memory data protection mechanism, and this is what is going to allow to protect your data during failover so that you don't lose that cached data if a controller is ripped out during a write process or what have you. Next, we have the ability, this HA Manager is what's actually going to allow those different controllers to access the same storage pool. So you don't need to actually have completely dedicated hard drive or SSD arrays for each controller. They can access the same one. iSCSI Manager, you're going to see we are ALUA compliant, and that allows for pre-configured multiple paths within the system. So that means that you don't need to configure this failover or the migration of those services. The UC is already configured for this. Whenever you pull a controller, it will bring everything over to the other one as normal. We also have non-disruptive IP failover, so there's no need to retarget the LUNs and that kind of thing within your virtualized environment whenever that failover occurs. So you're going to see here in a minute, we're actually going to do a ping test to a controller that we yank out, and even the IP address, target information, etc., is all failed over to the active controller, the one that remained in the case of a removal or theft or even a protocol error. And once more, there's no client configuration needed. You don't need to configure this failover or multipathing from the initiator side of things. This is, again, monitored and triggered completely from the UC. So it makes it as easy as possible to set up this environment. Lastly, we have snapshot replications. A lot of you are probably familiar with this, especially if you've tuned into these webinars over time. What you're going to see with snapshots as normal, you get that 5-minute frequency so that you can ensure current work is always safe. And again, as before, these are read-only snapshots, so it provides the best protection against ransomware because during an encryption event, those snapshots cannot be written to and therefore encrypted by the malware. And of course, you get that remote replication to a remote unified controller or a NAS device as well. So you could have multiple UCs in your data center or elsewhere. And if like a whole rack went down or something crazy happened on that floor, you could sail over to another UC in another location in the data center or externally completely. So some of the solutions that we actually are going to dive into are as follows. So one good use case that you'll see with these unified controllers is protection of your SQL database. It can be housed on the unit, all that good stuff, or housed on a virtual machine that utilizes this unit. And so what's going to be great about this is it's going to be protected by that snapshot replication. It's going to be protecting that current data as well with those read-only snapshots. What we're going to see live today is kind of a multi-path setup where we do an IP failover and the storage is migrated across to the remaining controller. All of this is going to be happening while a VM is being stored inside of the unit. And so we have VM storage with Hyper-V and with VMware and a couple other of our virtualization providers. But as we mentioned, we're going to be talking about how Hyper-V integrates with Active Backup for Business as well this time around. So we're going to go ahead and dive into a demo here. So just one second. So here we are in the Unified Controllers main UI. This high availability manager is actually going to be what opens up each and every time you turn on the UC itself. Just going into menu here, you can see it's pretty bare bones. We don't even have package center. We just have HA, snapshot replication, iSCSI, and storage manager. This device is purely iSCSI. And so you're not going to have some of those other extraneous third-party apps or anything like that for this device. As you can see, we have the controller option here. You can see the general status of the controller and how long each one has been up. As you can see, controller B must have been disengaged at one point where controller A was not. Under performance, you're going to have multiple different tabs, and you can just kind of scan through them. Memory, you can see how much you're using there. Controller A and B and network, what their network util is. And then also, whenever we see these graphs, they're going to take a few seconds to populate the data as time goes on. You can see it's writing to the graph right now. And likewise, in iSCSI, you can see the performance there and actually select which LUN you're actually looking at in those metrics. In Task Manager, you're going to be able to see what is actually being performed in the device. And under processes likewise. But in both those menus, you can select which controller you want to see. So you can see which controller is governing which process or which service as well. There you have it. So we're also going to take a look at performance alarm too. You can set up alarms based on different performance metrics. They can be system issues or service issues, kind of like the iSCSI plugin service or anything like that. You can set thresholds there and be alerted if that threshold is ever crossed, and then you can address that issue as needed. So what we're going to actually start doing here now is beginning our look at our current environment. You can see that we're going to go into iSCSI Manager here and go to LUNs. You can see that we have a LUN 2, which is on controller B, and this is going to be the controller that we focus on during this demo here. As you can see, there's quite a bit of data in here. There's about 50 gigs of data already taken up in the LUN itself. So you can see, you can gain a lot of information about the LUN just from that menu, just like before. And likewise, we have target 2 associated with that LUN. The hypervisor we're going to be looking at is an ESXi host at this .97 address that already has the targets set up inside of the device. So let's go ahead and pop into VMware real quick. We can take a look at what we're going to be focusing on. It's just going to be really fast here. So we have this Unified Controller 3200 Controller B data store already set up, and that's going to be the controller we're going to yank out. If we look at the data store, we have this Windows 10 virtual machine that we're actually going to be working with and actually transferring data into whenever we do the failover. So let me launch this remote console so you guys can see it at all times whenever we're doing this. Just a second while this guy boots up. So we're going to come back into High Availability Manager, let this Windows 10 machine pop up here, and we're also going to set up a ping test to controller B, which is at the .99 IP address. There we go. Let me go ahead and pull this window down. We're going to delete this this file, and we're actually going to transfer it right back in. It's just a dummy piece of data, and we're going to actually pull it from a network device. We're actually going to pull it from a NAS, everybody's favorite beast mode. We're going to pull data off of my home folder and into this virtual machine, which is living on that UC3200 Controller B data store. So as you can see, we have this network location, this network device that we're actually going to be pulling data into the virtual machine. So it's external to the device and going internal now. So let's take a look just to prove it to you guys in network. If we look at network interface, our controller B's IP address is that .99 address, and that's going to be the address we're pinging. That's where our virtual machine lives, and that's going to be the controller that we yank out. So let me go ahead and begin this dummy file transfer of about 20 gigs. And it's starting, and as you can see, it starts cranking away as normal. It's pulling data from beast mode, from my home folder, and pulling it onto the UC3200 at this moment. So what I'm going to do here is actually I'm going to get up and I'm going to go over and disengage this device. And what you're going to see is the transfer just is going to keep going. And it's going to, the ping test will time out for just a couple ping cycles. So, you know, we're talking milliseconds of time. And then it's going to immediately regain that .99 address as well. So just let me go and disengage this here. And so as we keep on going, you can see that the request timed out slightly. So we're only going to get 2 ping cycles of timeout, and then it's right back to .99. That is how controller B's IP address is actually being failed over to controller A. So that .99 address now is living on controller A. And as you can see, our transfer has continued, and even our virtual machine access is continuing as well. I set my iSCSI timeouts, the delayed acknowledgement, all of that stuff correctly as our guide details in our knowledge base. And because of that, the transfer never actually died on me. The virtual machine connection didn't die on me either. It's still plugging away as normal. So since it's actually failed over that service of the management UI, we just have to do a quick login. So as you can see, there's no interrupt in the iSCSI service. And whenever we pull up HA, once more, you can see that controller B is disengaged, and it's letting you know that there's some system errors, and that orange HA light is going to be blinking on your device. But you can see here on the right that we actually have the whole transfer still going, and we're still pinging that device as normal. So now what we're going to do is actually do a re-engage here, just like we did later in kind of at the tail end of the hardware demo. I'm going to get up here again and go and re-engage this device. You're going to see on that transfer grass, it's going to dip in performance for a split second, and then it's going to come back up just like normal. I'm still going to have connection to that virtual machine, and I'm going to be able to see that my transfer is good to go, and the virtual machine is still running, and it was truly a non-interruptive iSCSI experience here. So just 1 minute. As we disengage the device. And as you can see, we're still about we're not even halfway done with our transfer, but after I just re-engage this controller B, you can see it's processing and booting controller B now. It's already recognized that it's there, almost like as quick as a snap. So now what it's doing is it's booting controller B, ensuring that the health is okay. Once it does that, it's going to begin moving that .99 address back across to controller B as it was before. And it's what after that's all done, you're going to have a active controller once more, and it's going to be back to normal. You don't actually have to do any operations to bring the services back over, bring the IPs back over. It redistributes the configuration as it was before the incident occurred or before the upgrade occurred itself. So you're going to see our transfer fell down here because it's failing over that IP address. We've set our iSCSI timeouts correctly. So once this comes back up, you're going to see the transfer begins to climb again because the failover has finished and reoccurred within our timeouts, with our goal of less than 30 seconds and within our timeout thresholds, all that good stuff. So you can see it's climbing back up to normal. And I'm going to walk back over to my device here and kind of log back in. And you're going to be able to see that the whole UC relationship is no longer booting, but it's actually right back to normal. And as you can see, it's normal function again. .99 has been failed over. The iSCSI transfer, the iSCSI service is still working, and our transfer is still running. Never even really a hiccup for a noticeable amount. And as you can see, we're already at 10 gigabytes on that transfer, and we can continue going there. All right, let's go ahead and demo Hyper-V now and the new active backup integration with that hypervisor platform specifically. So let's go ahead and pop into actually a remote session here. And in this session, you're going to see that we have, Hyper-V service actually running on this Windows 10 device, and we have a database server and an elementary OS server as well running in this device specifically. So what we're going to be mainly focusing on here is backing up these VMs directly. So keep in mind that we have database server and elementary OS inside that hypervisor right now. The big thing about Active Backup for Business now is under the virtual machine tab. If you guys need a deeper demo into all these other tabs and all the other functionality of Active Backup, take a look at our DR webinar that we did a couple months ago now, or you can also reach out to your rep for some more information. We're just going to be focusing on the Hyper-V integration here today. So in virtual machine, you'll notice that we now have a Hyper-V tab on the top here. So if we click on it, you're going to see we can see into our various servers that we have attached to Active Backup for Business. We have a .96 and this hyper-v.slab.local housing that database server in the elementary OS, which is actually the server we're remoted into right now. Under Manage Hypervisor, this is where you're going to actually add your various Windows servers or anything else that's running Hyper-V at that point. You can have any amount of hosts actually paired to this, just like the Center vSphere. And it's pretty simple to add as normal. You just add your server address, and it does everything through WinRM, and you are able to use the HTTPS port as well if you so choose. So once they're all added, it's going to actually plug directly in to Hyper-V and just see directly inside of the host. And what's really great is you don't need an agent on the VM itself or inside the hypervisor itself. It's completely agentless, just like for the VMware integration. Another thing I wanted to show you guys is that if we go into database server or anywhere we have a task, or even whenever you're just creating a task from the very beginning, you're going to be able to see that we can actually add a schedule specifically into the backups now. So previously we couldn't set up like a schedule based on a time, like a time schedule. We could schedule it for it to happen every hour, but you can actually block out times where it's acceptable to be backing up now with this new Hyper-V integration. You can configure this backup window here using this table and actually block out times of the day or the week that it wouldn't be acceptable to be backing up. It's very similar to our motion detection portion of Surveillance Station, if you're familiar with that. So to the piece de resistance, we should actually go into restore here. We're going to restore this database server. We're going to take this database server and actually take this Hyper-V VM that we've backed up, this database server here, and we're going to dump it just directly into VMware. The added special benefit on the side of having this Hyper-V integration is Active Backup for Business does not care where the virtual machine came from. It can take virtual machines out of Hyper-V and dump them in VMware, doing an instant restore or a full restore. And likewise, you can go from VMware to Hyper-V. So if you're housing your data center in a VMware environment, but you have Hyper-V clients, you may not even need to actually migrate them over unless you just prefer to use VMware across the board. However, you could definitely have them fail over to your VMware environment and just plug those VMs right in using Active Backup for Business. And likewise, it's going to help with migration as well. You can back up the Hyper-V VMs and then just restore them directly into VMware on the client site, and you don't actually need any middleman conversion tools or anything like that. So we're going to go into vSphere here as well and just take this Hyper-V VM, this database server, and restore it instantly into VMware in the interest of time. So we're going to select, go to VMware vSphere, hit next. I'm going to do an instant restore. We're going to do this Hyper-V task here. So again, we're going from Hyper-V into VMware with no middle conversion. We're going to go into our .97 host, but you could also drop it into vCenter. So that's why, just failing over a Hyper-V VM, you can now just drop it into your vCenter at your data center if you offer disaster recovery as a service or anything like that. Drill down here and select your network. And whenever I hit VM network and hit next, we're going to be able to power on automatically and apply. Before I do that, I want to open up the logs, show you guys how quickly this happens. And there we go, immediate reaction from ESXi. And you can see that the database server is already booting up, and we're good to go at that point. And you can also do a full restore if you so choose. So that about wraps it up for this one. Feel free to reach out to sac_sales@synology.com if you have any product questions, system design, or specification questions. If you need a reseller referral or recommendation, we're happy to do so. We have a wonderful network of partners that we can speak very highly of. And as for if you want to become a reseller, feel free to reach out for a partner registration, and we will also get pre-sales support and product trainings just like this webinar. Feel free to join us next month. It's going to be pushed up a little bit. We're not going to be doing it the last Thursday of November. We're going to be doing it the 21st because the holiday season is rolling around, and we would like to have as many of you attend as possible. We're going to be looking into advanced permissions on DSM, so please keep an eye out for that. And thanks once again for taking the time out of your day to learn with Synology. See you next time.